I'd like to share with you an idea that has been long around for a long time. But we never realized that it should be finally implemented. I cannot say why we waited so long, perhaps because it was obvious. The idea stems from very old Donald Knuth's idea of virtual phones, which were implemented at some moment by Hans on the fly. So phones can be generated within TeX, and this is idea behind that talk. Let's recall what is an open type math. This is just repetition. Each time I talk about math fonts, I show it, just to, not to remember every icon, but just to show what a beast is a math font. And by the way, this talk is a good illustration of the bon mot of the conference. Here we have premises. This is our starting point. This cannot be changed. We have it just. So this table does not specify problem of sub and superscripts which are crucial in math. And virtually any glyph can be accompanied by subscript or superscript, or subscript and superscript of second order. That's all. Third order does not exist at the moment. So we didn't want to add superscripts and subscripts to all glyphs, because it would be too many glyphs in the font. We already have more than 4,000 glyphs in every font, counting subscript, chains, extensible character. So we tried to limit it. And it's perhaps worth it to notice that only among fonts I know, actually optical scaling, perhaps Lucida also, but actually computer modern fonts have optical scaling, that is, each font, each variant has slightly different shape. But for example, Euler, well-known font, has just non-uniform scaling, and that's all. So this is the same, they are the same glyphs, but diminished and extended a bit. In TeXa we used the same trick. If we didn't use it, the result would be something like that, which does not look good. This, without extending, subscripts are too small. So I will shortly come back to this subject, because this actually the subscript need not to be in the font, as you see. So, coming back to creating an open type math font, we have a lot of different elements, or subfonts, or scripts, or whatever, including such funny things like 4-letter font containing 4 Hebrew letters.
Left to right. Not left to right. Not like that. I get the direction.
Okay, you are right. My mistake. And now we need a font editor which takes all the source fonts, provided they have proper licenses and so on. Here is an empty place, but this is a place for math table and additional whatnots, which is added by font editor. And now we have math, very complex, heavy font. Oh, it has, of course, advantages, because now such formatting editors like Word or TeX or whatnot can make use of benefits of the standard form of the font. But now we move to our predilections. Actually, TeX can play a role of font editor, as showed a long ago Hans. Font can be combined within TeX, especially LuaTeX, because LuaTeX has an engine that makes it possible to manipulate with internal text structure. So, such a font can be created on fly by LuaTeX. Of course, LuaTeX is a simplification because this is engine and macro packages are needed. Either it will be LaTeX or context or our homegrown package, doesn't matter. I would not discuss about the predominance of Christmas over Easter or vice versa. Hans doesn't like it. So, anyway, very often we don't need this whole bunch of additional fonts. Main font, that is, say, Calibri, Cambria, Times, or what, and math symbol that is, in most cases, sufficient to typeset a math book. This is our practice. It's not an idea. A few times we are asked to, okay, we use such and such font for typesetting our books. Is it possible to have it with math? And usually this overload is not needed. So, within LuaTeX and not especially complex macros, it's possible. Here is just an example, triple example of joining math from déjà vu math and déjà vu sans serif as a main font. After such a short preamble, our OTF math, this is our macro package, then you can use normal text notation to obtain math with sans serif. Another example. One may discuss whether this is proper square root for sans serif. It doesn't look bad. And the last example, you can see that braces are taken from serif déjà vu, and the variable is just sans serif. So this is, in principle, possible. So what's needed? What's missing? So what is wrong with that? Details. Even such simple glyphs like math operators and rectangles has tiny details. Each ending is different. For example, in Pagella we use so funny incisions at the ends. It's our idiosyncrasy, but okay. Could be all if, how to say, again, our predilection. We like to have a possibility of such tiny adjustments. To, for example, in late modern, it would be really, it would look very bad if we don't use the rounded corners and endings, because whole math is designed in such a way. So, again, let's reformulate the problem. We have a given form, main form, and we want to add an adequate, that is optically consistent, math companion to it. I presume that additional forms, such like fracture, like blackboard ball, can be added on the fly using just tech manipulation. Adding this font is rather simple and has this advantage that you can choose any font you like. Karel doesn't like this serif blackboard bold. Please use the sans serif if you prefer. So the procedure is straightforward. Prepare a generic set of Lua-Tech macros to manipulate with font set. Then prepare generic set of metapost macros. We use metapost for generating our fonts, so that's why we would like to use the same engine. And now the only problem is to provide a set of adequate parameters for this math font, controlling stance, size, incisions, ending of braces, and so on. Yeah? And good news is that the first two points are practically accomplished, because this set macros, Lua-Tech macros, as you saw, works. We have it. Unfinished, but it works. Metapost macros are also practically ready. That's because we did our fonts just in such a way that we did a pretty general set of macros for generating math symbols and shapes, and we just fill around with parameters to change, changing from font to font, sometimes a piece of code. This should be eliminated. It would be not should be something like simplified, computer modern set of parameters. It should, I would say that test bed is prepared. So now we are on the edge of predictions. When we can expect finishing this implementation of this idea? I would say that the state of the art looks like this. This is, I do not know if you can see this, but this is cello. Cello, two planks, and back of cello is drawn on it. And so the cello is nearly ready. You may ask, will it enter? But the idea is there. We know how to finish it. Now we have to finish it. But as we emphasize in our invitation for Bachotek, predictions are very difficult, especially if the future is concerned. This is favorite saying of Niels Bohr. So, that's all. I believe that implementing this idea would help us. This is not meant as a... I do not know if anybody else cares about it, but we have from time to time such a problem to solve because of wishes of our customers who are typesetting math or physics book. So,
but your problem is that you say that it can be done. What happens if you say it cannot be done? For your customers, just say that it can't be done. It's easier.
It seems interesting. So, sun is appearing. Really. Let's hope that next Bachotek meeting will be a bit warmer with less of rain. Let's check. I'm going to check next time. Yes. And that's all. So.